Hi everyone, this is the video that goes with my first GCSE worksheet on trigonometry and Pythagoras Theorem. I'm in a slightly different setting than usual. I'm staying in an Airbnb, a beautiful Airbnb in the south of Spain. It's very nice, but windy, so if you can hear that outside, I apologise. Anyway, before we get into it, as usual, the image of this worksheet is on my Instagram page, as well as the answer sheet and other bits and bobs that I post, so head over there to check that out. So this worksheet is all about Pythagoras' theorem. Firstly, what's a theorem? Mathematicians love a weird word. A theorem is basically a recipe. So Pythagoras' theorem says, if you give me a right angle triangle and you give me the lengths of two of the sides of that right angle triangle, this recipe will tell you how to find the length of the third side of that right angle triangle. You see, theorem, recipe. So many people have heard about Pythagoras and Pythagoras' theorem because this thing literally crops up everywhere, and you probably see it in the examples that I use. You know, like I think I've got an example about a ship and a lighthouse and working out the distance between the ship and the lighthouse. Yeah, it's everywhere. It's really important, but the main thing is it's super easy. Once you get your head around this, you'll be aware. Anyway, enough of me going on. Let's get into the worksheet.
Alright, this is the worksheet. It's very yellow. As I said in the introduction, mathematical theorems are like recipes. They tell you a bunch of things that you need and then give you a way to create something from these. Pythagoras' theorem is no different. So it says, if you have a right angle triangle and you know the lengths of two of its sides, it doesn't matter which, you can find the length of the third side using this equation. A squared plus b squared is equal to c squared. Let's look into this theorem some more. Firstly, what's a right angle triangle? This is a triangle that has one angle that is 90 degrees. This here is a right angle. This is a 90-degree angle. It's like a little corner. You'll often see a small square in the corner, and this tells you that this angle here is 90 degrees. Secondly, what do we do with the two sides whose length we already know? Like, how do the lengths help and where do they go in this formula? Well, it depends on what sides they are. The side that is opposite the right angle is always the longest side of the triangle and is always the C in this formula. C is often called the hypotenuse or hypotenuse. So always remember, this longest side's length must be C in this formula. These other two sides can be interchangeable. We can label this side's length as A and use it as A in this formula, and therefore this side would be labelled B and we would use this side's length as B in this formula. Or we could do the other way. We could have called this side B and used this side's length as B in this formula, and then we would have A here and we'd use this side's length A here. It doesn't matter. Right, let's look at an example so we can cement this new learning into our brains. Example, find the length of the side XY. This question asks us to find the length of the side XY of this triangle. This is the side XY, as it's the side that passes between the vertices or corners X and Y. Pythagoras should help us find this length, but we must check that we have everything we need to use Pythagoras' theorem. Firstly, the triangle must be a right angle triangle, and secondly, we must know the length of two of that triangle's sides. Okay, let's look at this triangle. We have a right angle here, so indeed, yes, we have a right angle triangle. And secondly, do we know two lengths? Yes, we know the length of XZ, it's 3 centimetres, and we know the length of YZ, it's 5 centimetres. Brilliant, so yes, we can use Pythagoras' theorem. Therefore, let's write out the formula. Okay, now we know we can use Pythagoras' theorem, we need to make sure we use it correctly. That is, we need to input the correct values for A, B, and C. I always tend to do C first. So remember, C is the hypotenuse. It is the longest side of the triangle and is always opposite the right angle. So going back to the triangle, we can see that YZ is the hypotenuse, i.e. its length, 5 centimetres, can be used for C in the formula. We need to replace this C with 5 centimetres. Next, A and B. Like I said, A and B can be interchangeable. We can take either this side as A or this side as A. It doesn't matter. I'm going to take XZ as B, so its length, 3 centimetres, will replace this B. And I'm going to take the side XY as A, and we don't know this, so I'm going to leave this as A in the formula. There we go. Right, if you've used my algebra worksheets, then you should know what to do next. We need to find what A is. How do we find A? We need to rearrange this equation to make A the subject and simplify our result. And there we have it. We've calculated that A, which is the length of XY, is 4 centimetres. Don't ever forget your units. Now note, here we have a square root, and therefore we should actually have a plus or minus sign in front of this 4. However, just think about it. It doesn't make sense to have a negative length right now in your stage of mathematical learning, maybe at university level. So therefore, you should always choose the positive solution. So we have positive 4 centimetres. And there you go. That's the first example. Okay, so I've put together some more examples here that are all a bit different and range in difficulty, but should highlight the many ways you can be tested on Pythagoras' theorem. I'll go through these examples now. However, if you do want to test your knowledge, you could always pause the video here, try out these examples first, and then watch me go through them and make sure your workings and answers match mine. Okay, let's look at this example here. A boat has the coordinate 2, -7, and the lighthouse in the distance has coordinate -3, 5. Find the distance between the boat and the lighthouse. Always, when you get questions like this, draw it out. I just think that drawing things out really helps you visualise the problem and sometimes can show you ways of solving things that you wouldn't be able to figure out by just working through things in your head. So that is what I've done. Here's my boat, and I've put it on a grid system, i.e. I've put it on a graph. That's the y-axis, this is the x-axis, and I've put it roughly down where I think 2 and -7 is. So we've got a boat there. And then the lighthouse, which is at coordinate -3, 5. And we want to find the distance between the boat and the lighthouse, which is this line here. One great thing to notice is that, okay, we want to find this distance, we don't know it, but because we've got a grid system, we actually can draw a line down here and find its length, and a line along here and find its length. These two lines together form a right angle, and therefore we have a right angle triangle where we know 2 of its sides. Therefore we can use Pythagoras. Okay, what is the length of side A? Notice that this side is parallel with the y-axis. Therefore we're going to be using the y coordinates to figure out what the length of A is. So we could actually count it. We could go, right, we're starting at 5, we go 4, which is one number, 3, which is another number, 2, blah, blah, etc., etc., and you would eventually get to 12. Or you can do 5 minus -7, which is 5 plus 7, which is 12. So the length of side A is 12. Now do the same to find the length of side B. See that B is parallel with the x-axis, so we're going to use the x coordinates. This corner here has an x coordinate of -3, and this coordinate over here has an x coordinate of 2. Again, count how many numbers we have to touch to get from one corner to the other. So we start at -3, we go -2, that's 1, -1, that's 2, 0, that's 3, 1, that's 4, 2, that's 5. Therefore, B's length must be 5. Or you could say 2 minus -3, which is 2 plus 3, which is 5. Okay, we have the length of A, we have the length of B, and the question is actually asking us for the length of C. We have a right angle triangle, so we can use Pythagoras' theorem. Write out the formula, c squared is equal to a squared plus b squared, and just input your values that you know for A and B. So we get 5 squared plus 12 squared, which then reduces to 169. The square root of 169 is 13. Remember, we take the positive solution because it doesn't make sense to have a negative length. And notice here we don't actually have any units because the question hasn't given us units. So that is just fine. Right, second example, bit harder. The length of the hypotenuse of a right angle triangle is 3 root 5. Give the lengths of the other two sides of the triangle given that the lengths are integers. First thing, what is the hypotenuse? The hypotenuse is the longest side of the right angle triangle. It is what C is in this formula. So what we can do is we can say, all right, C is equal to 3 root 5. Therefore, C squared is equal to 45. Okay, what else do we know? What other information have we got? Well, we've got Pythagoras' theorem. So we have C squared is equal to A squared plus B squared. And we know that C squared is equal to 45. So we have A squared plus B squared is equal to 45. And what the question is asking you is, give the length of the other two sides of the triangle, given that the lengths are integers. So we need to find what A and B are, such that they give 45, and that these A and B are integers. So what you can do is you can just write out lots of squares. So what's 2 squared? 4. 3 squared? 9. Blah, blah, blah. And then you look at all those squares and you see, okay, which two when added up give 45? And that's what I've done here. I can't write it all out because I don't have that much room on these worksheets. But what I've found is, if we take A squared as 9, and B squared is 36, then 9 plus 36 gives 45. Therefore, A must be 3 and B must be 6. And the final example, we have another grid one. Work out the exact distance between the 2 points 1, 5 and -3, -1. Again, like I said, it's probably good to draw a diagram, like sketch these coordinates out on a grid system. I haven't done it here because I know I keep banging on about it, but I don't have that much room. Right, first thing to point out is it says work out the exact distance. When questions say exact, this means your answer is probably going to have to be left in surd form, i.e. we're not going to do anything to certain decimal places or significant figures because those answers aren't exact. We need surds or integers, round numbers. Next thing is we have 2 grid points. We're going to have to find an x distance and a y distance, a bit like we did, up here in this problem. A was the y distance, it's parallel to the y-axis. B was the x distance, parallel to the x-axis. And then when we found those, we then could find C. It's the same down here. So that's what I've done. So there we go, we have a x distance and a y distance, and these are our A and B. Input these values, so we have 4 squared plus 6 squared, which then gives 52. So we have C squared, which is what we're trying to find, is 52. Square root of 52. This then simplifies to root 4 times by root 13, which is 2 root 13. And there we go, we have an exact answer. There's no units because there was no units in the example. And that is the last example and end of the worksheet. I hope you found it helpful. I've put together an extra 3 questions that you can test your knowledge on even further. The workings and answers that go with these are given on the answer sheet that goes with this worksheet, which is on my Instagram page. As usual, there's a link in the description box below, which should take you to my Instagram page. And yeah, that's everything. Cheers for watching.